Hello everyone, my name is Peter Schaknat. I am the Managing Director of Schaknat Electronic in Bauer, and today we are optimizing an old Scania R580 Euro 3. A few key facts about the truck. This is a Scania E580 Euro 3, the old unit injector or PDI engine with a 15.6 liter displacement, 580 horsepower and 2,700 Newton meters of torque in its original configuration. It has an opticruise transmission with a clutch pedal for starting off. The truck belongs to a very good customer of mine. It's from the Kiefer Transport Company. This is the truck of the senior boss. He just wanted us to check the vehicle over again and optimize it nicely. It already has quite a few kilometers on it. And as I said, let's see what happens. We measure the truck either in 4WD. Now I'll read it out using the CAN bus. And then we'll take a look at the data. We'll do that here again via OBD. Let's go in here. It has its OBD connector inside the door. It's up here. You can see it here. Then we'll read out the data again here. The basic data of the truck. It also includes things like, as I said, everything related to engine management. So, as I said, injection timing, injection quantities, torque, boost pressures, everything that's important for us. It's also always important that we read a complete backup so that, as I said, we can properly analyze the stock performance on the test bench and build on that to optimize it. So, let's take a look at the R580. These are also my favorite engines, the old PDEs, because they don't have as many emission standards yet, not such big particulate filters and all that. They're also really great to optimize, so you really get something out of them in terms of fuel and performance. We're reading here via the data bus, also via the CAN bus. That's a pretty secure transmission rate. We flash everything here via OBD. We don't have to go directly to the control units. Instead, we do everything via OBD diagnostics. So first the engine and then the transmission. You can see it has extracted the hardware number, software number, and ID. DC 16003, everything matches up. Parking brake not engaged. It'll take about 10 minutes now to read out the software, so we'll see each other again later. We're going to do the initial measurement now. I'll turn the radio down so you can hear me better. We're going to accelerate once now, then let the truck coast. So first we're going to select the correct gear. I've also changed the top speed. We'll be driving in 11th gear again. Gear. It's also important that we warm up the tires a bit so we get some temperature and have traction on the rollers. Even though we're pulling it down with the hydraulic cylinder with 5 tons of force, it's still important that we have proper grip. This is an opticruise with a clutch pedal for starting off. The parking brake is off. At some point, we'll get going. Then you switch to manual. We're now measuring in 4WD. With four-wheel drive, it's always very important that the alignment is correct. The problem with four-wheel drive is if the axle starts moving left and right again, that would be extremely dangerous. It's very important that when we're measuring on all four wheels, the alignment is absolutely 100% correct. Alright, let's take a moment and warm up the tires. Now, it's basically like on the road, shifting up through the gears now, 2, 3, 4, up to 11, gear. Alright, number 5 there. Shoveling, and at the moment, traction control is off. You can hear it with the V8 V8 engines. They have a great soundscape. It's important not to measure the engine while it's cold so that it reaches operating temperature. Because of the turbochargers, so nothing gets damaged at the hot spots, the engines are also allowed to run on after the test bench, since they still experience considerable stress there. Alright, 10th gear. Now let's take a look up here. Now you can see here, we've increased the top speed because the 11th gear is now geared so long. So you can see here, it now goes beyond 90 as well. You need to see how high the 11th gear actually revs. We're now in 12th gear. I'll shift it down now. Now, beforehand, you always have to make sure to measure so that it's important not to hit the rev limiter because otherwise it messes up the measurement. Of course, we don't want that. Let's see, you can see it's revving in 11th gear. There, it hits its limiter, and that's fine. Now you can clearly see that in 12th gear, it even revs up, and it goes up to 100, over 120, and even 130. That's a really long rear axle ratio. With the introduction of the new racing stars, they are now able to reach a top speed of 160, or even up to 180 kilometers per hour. After that, we will also turn on the fan. I do that right here, using my keyboard. If we do 4 or 5 measurements in a row, you'll also see that the power gradually decreases because the truck limits the temperature. Alright, then let's start with the 11th gear as we begin. Now, we'll carefully synchronize the RPM right now. Now I'm going to set it to 1000 revolutions here. Up front on the monitor, so we have a reference point. Alright, let's check 1000. Good, then we'll start the measurement. The principle works like this. We're going to brake the truck now at 800 revolutions. Then we'll rev it all the way up to maximum RPM and then let it coast down. By coasting down, it measures the power loss, and from that it can calculate the torque and the kilowatt output. That's what's interesting for us. You can also see on the curve if it's running smoothly, if it's properly tuned, which is important for us. Alright, let's bring it down below 800. Then we'll start braking it. Then you let the torques build up. That way you also have the turbo when you build up the torque. Then you start the measurement. Now it's releasing full torque. This is basically full throttle up to the maximum RPM, up to 2,300 revolutions. And then I shift to neutral. You can definitely hear that it's making quite a bit of noise. As it coasts down, you can see the RPM is gradually dropping. While it is coasting, it measures the power loss in this way. But you can already tell I've already delivered massive torque. That's just insane. Now I'll do 2 or 3 baseline measurements so we have average values to see if there are any temperature limiters and also to make sure we can compensate for the test bench tolerances as much as possible. And then we'll do the optimization and see what results we get. Let's be surprised. So Kevin, we've now done the measurement, both the baseline and the post-optimization measurement. I'll just quickly explain this here now. As I said, the truck is impressive. It has 2.4 million kilometers on the clock. And that's why I say the old unit injector engines are really top-notch. They're really great. Top-notch, last forever. So you can see the initial power here. I'm saying for 2.4 million kilometers, it's still almost 3,000 Newton meters of torque. That's really an outstanding performance for the engine. Now we've tried, as you can see here, again across the RPM range, to keep the torque as high as possible for as long as possible. so that it really delivers power in every RPM range, making it fun to drive. You know yourself, these engines have a lot of exhaust manifold gasket problems, all due to high temperatures. So we try in certain areas to run it a bit richer so that the exhaust temperature comes down and the engine's longevity is ensured. As I said, peak performance compared to stock. This is the original case, so you can't over-rev it. This was primarily designed for torque delivery. We don't want to wear out the engine, but rather make sure it lasts another 2.4 million kilometers, ideally. That would be optimal. Now, I'll also teach you about the transmission. Again, we're setting it up for comfort so that the whole thing is durable, so that the shift strategy is nice and smooth, like in other vehicles, so that it shifts up early and still has good torque at low revs. Exactly. Yeah, great, perfect. Thank you very much. You're very welcome. It was super interesting to work on such an old truck again. I really enjoy working on these old trucks. Of course, as you might expect, we usually work on the newer engines, but now we've worked on an old one again. As you can see, we can definitely cover the entire range. As I said, if you're interested in the topic about the Scania R580 Euro 3, feel free to check out our website at www.schaknat.de. You can also write to us or give us a call. We'd also be happy if you subscribe to our YouTube channel. If you just leave a comment below about what interests you or what else you'd like to see, we can try to address it in the next videos. I'm glad you tuned in. Thank you very much. See you next time. Ciao.